Hello and welcome to a new episode from Just Enough series. In this video, we'll discuss front-end architecture and most importantly, we'll speak about these different components or different building blocks inside any front-end application and how they are used, what they are, how they interact with each other, and why we have this separation inside front-end. And if you haven't heard about these things, probably inside your code you would have like some kind of pasta code inside it, like everything is going inside each other and you don't know where the separation starts. When I use to create a new component inside React, or when do I create like this different abstraction, all of this is called like design patterns, but these are the most important patterns inside any front-end application. So we'll discuss from outside the concepts, the abstraction from all of these, how they interact with each other, what they are, and we will not show any code at the moment. We'll just discuss these from concepts part or the theory part. And in a future video, I will create another one where I would write code using pure JavaScript and we will show these different components and how we actually use them inside the code. So don't forget to subscribe to see this video. And without further ado, let's discuss these different building blocks. And the first part that we'll discuss, or the smallest part in any front application, is the component. And the component is the smallest unit inside any front application. So we could take, for example, we have a contact form, and the contact form have a name field and another field for sending the message, and we have our submit button. So in this case, a component would be submit button, or it could be just the message or the small field text area that contains the message. It could be the name or the field to send the name, or the other one to send the email. So the component is the smallest part or the smallest unit for our application. And we would have, of course, like we wouldn't have one component, but we would have multiple components. And all of these components are the things that build our UI. And components, of course, like components as well, could have components under them. So it's used to build like more complex component in this case. So you could think of components or like atoms and building more bigger atoms, which would be like in this case molecules and so on. But the most important part about them is that they don't have any logic. They don't call the API, they don't interact with another component, they just have UI stuff. So the most part about them would have HTML and CSS and very minimal JavaScript, maybe just like passing some props into them. For example, the name here or the field, because this would be like a text field and we have like label at the top here on this part. So in this case, we would have like a prop into it, for example. So in this case, component would have like mostly props, UI stuff, HTML, CSS, but very minimal JavaScript. And where we store most of the JavaScript part, it is the second pattern or the second part inside our six diagrams that we show at the first of the video, which is containers. And containers are the things that controls components. And why do I say control? Because the older name, if you know, like some like the MVC model, basically you have like model, view, and C. In this case, it's used to be called like controller. This is like in the old versions. Now they call it container. Sometimes they still also call it controller. Yeah, it's a little bit of an interchangeable name, just to be aware that this name exists. But the most important part about container is that they mostly hold JavaScript. And of course, they collect, I usually say collect in this case, they collect these different components to build the bigger structure. So in regards to our contact form, in this case, the bigger form from the outside, this would be the container, and the container does the heavy lifting that we need. For example, it could do validation, it could call API from the outside, it could store different data, for example, it could collect translation, it could do transformations, for example. So it does a little bit of more heavy lifting work. And in this case, we put it inside a container. Whenever you find inside the components that you are building that have like many JavaScript and more complex stuff, most probably this is not the right place. It should be inserted inside the container, and it would hold most of your logic in this case. And of course, like containers as well from the outside could have a container collecting them. So a good example for container, inside containers, you have your home page. And for the home page, you have like your home page in this case, and you would have like the first part, which is like the intro part, and you would have like here there is a logo, there is here some video, and there is some paragraph, and there is a button in this case. And this button like maybe like sending to an external service. In this case, you could collect all of these into a component, not a container. But you would go under this one, you would have another contact form, and you would have another form, and maybe you would have some footer, and this footer called the API to get like different links and so on. So in this case, this footer would be a container, and this form would be a container, and this other form, maybe like live chat or something, could be a container as well, and live chat would be here on this part. This also would be a container. Like this upper part is just like view part, so in this case it could be a component, and the page would be our container part. So it is the part that is collecting all of these things. So this is one example for a container inside a container. So to recap, JavaScript mostly would be inside the container, and components would mostly contain like HTML and CSS part. Most of the logic should be moved inside container. Some extreme cases would be inside a component, but most of the time it should be inside our container. Now let's move to a new page and write what we have done again. So we have our container, and we have our component, and another component, and another third component. Now comes the third part, and it is called higher order component, or for short we use HOC. This is like the short term use for it. And the idea for HOC is that it is mixture for, like we said, for container we have JavaScript mostly, we have HTML and some view basically, or some most of the time we call UI, or let's say like 100% UI, 100% JavaScript. HOC is a mixture of both of them, so it's like 50-50. So when you have like a mixture between JavaScript and HTML, we would have most probably HOC. And the idea of HOC is UI logic reuse. A great example for an HOC, we have the dialog. So this is one of the great examples for an HOC. So the idea for a dialog is that when you build it, you usually have the dialog as an element inside you, and you have like the different things for it, but it also contains open and close as well, open method and close method. And some implementation would say, okay, we want this dialog to have like if condition. Another implementation would say, okay, no, we need like some CSS to show and hide. So in this case, there is another implementation. Maybe a third implementation, they want it to come from the side. So if you are not aware of the HOC, you would usually have inside this container, you would have the dialog. And in this case, you would implement the open and close methods. And inside another container, because it's not a single container, but rather multiple containers, you would also have the dialog components, and you would have the open and close methods, or the open and close implementation. And then comes the product manager and say, okay, no, we don't want it to show and hide, but rather to come from the side and do some fancy animation. So we would go to this container, change it, go to this container, change it, and send it, and then comes through the testing, or like after it goes to production even, oh wait, there is another container that you forgot about implementing this part. And this is the problem, is that you like forgot to implement this part because you weren't aware of it, because your code base have like maybe like 500 containers, not just one or two. In this case, we store this logic or this part inside an HOC. And to think of an HOC, it is not something, it is like inserted inside it. Like when we see it inside the code in the upcoming video, HOC is basically injected and passed from the outside. So it is basically like wrapped from the outside. You could think of it like a hat or something that's wrapping your container, or like a shirt. It is not like defining you, but rather just like from the outside to like fancy more of it. So the dialog component is inside the HOC, but when it is wrapped around the container, like usually would be, for example, we call it with dialog, like when we write it as a function, and we have our like not this one, but rather let's say home page. It is wrapped around like a function. In this case, this thing or this function would add the dialog, would insert it, and at the same time it would pass two methods like the close and the open, or maybe more if we need. And the homepage would have like a button, for example, or maybe like a timeout or something to show it like as a pop-up. Don't do pop-ups, it's really bad. But you would have like, for example, a button, and in this case button would click like would invoke the close and would invoke the open as well. It would call, and the real implementation is inside our higher order component, which have like it is being like written as this method. But you could think of it like an outside component, and it has only one place for the dialog and a single place for the implementation as well, for open and close. Maybe there is also other things for HOC, but this is like one of the simplest and easiest thing to use with a dialog. Other implementation, maybe someone would like to do with footer, like footer to be in every page instead of passing it inside the container. Like instead of having footer inside the container, it would be like wrapped from the outside, because for example, I don't know, like it would be a little bit complex, like the container, for example, calling something inside the footer. Yeah, or for yeah, this would be like good example just for easiness for now. So you could think of like the dialog, one of the best examples, but other examples could be like pages, tabs, like different parts. Like there are more examples than this. But the main idea is that whenever you feel or you see inside the code, oh, there is like some repeated logic between different containers. Like you have a container and the same logic is repeated inside the container, and there is a high coupling between this logic and another component, and it's always repeated in another container as well. In this case, okay, this is now a higher order component because it has two things, logic and JavaScript, like logic and UI as well. In this case, you would say, okay, this is an HOC. Now let's go to the fourth element, or the fourth the fourth thing that we'll discuss, or the design pattern. I would think of the design pattern. So let's write it again. So we have our container here, and like we said, the container is the thing that has mostly JavaScript part, and it has component inside it, component again, and you have another component, and you have the HOC from the outside. We said like it's, you can think of it like a hat. Yeah, I'm a little bad at drawing. So you can think of it like a hat. So it is something just like around the container. And it basically passes method. So the first part would be the service. Okay, what is a service? A service is something that is 100% code. It doesn't have any UI. Like this one, we said, yeah, might have, like it has mostly JavaScript but has some UI. This one have mostly UI but less or non-existing JavaScript. This has like 50-50, but this one has no UI at all. And most of the part, it is a service that is calling something outside your control. So it could be a third-party library. It could be one of the DOM API. It could be a website or something from the outside world. So let's define it. Like, for example, we have an service that for doing API calls. You could have another service for translations. So we write here, sorry about this writing, would improve in future videos. And you have another container like we said, like translation, you won't have jQuery. I don't know why you would need it, but it might happen that you have to use jQuery. Or another one, for example, I don't know, like for some reason you might, okay, I need Lodash, for example, or without Lodash, yeah, let's go away from Lodash, but rather local storage. So all of these are services, and they are the things that your container would interact with. So instead of adding, you would say, okay, there is a question, why or why not add the API here? Like why I just do like fetch inside the container, because I see it like in many videos and so on. So they usually like add fetch inside the container. The idea is that inside your application, you wouldn't have one container, but you have like multiple containers or mini containers. You have one for the home page, one for the FAQ, maybe one for the members page, one for notification, another one maybe like for messages and so on. So today we would say, okay, we are using jQuery. Okay, we would like to deprecate jQuery and use another service instead of this one. So in this case, you would have to go to this container, remove this one, remove this one, remove. You have like 500 containers. You have to replace it in everywhere. For example, as well, API, you would say, okay, I wouldn't use the API today. Like I wouldn't use fetch here inside this one, and we have like a string inside it. You have to write this string inside this container, and you would write the same string in another container. You might say, okay, I would use constant for these strings and then reuse it. But how about reusing the whole stuff, not just the string? So in this case, we would add all of these third party. It is most important part. It is a third party dependency from the outside. In this case, we would add it inside a service. For example, as well, translation. And instead of implementing the logic for translation inside the container and implementing the logic for the translation in another container, we collect all of this and add them inside a service. And the service in this case would be the third party dependency. And you would have in your application many services in this case. And services go in hand with another component, which is the adapter. So let's draw this back again. And we have our service, like we said, but the service doesn't call the API directly. Maybe I lied about it. It rather calls an adapter. And this adapter is the actual thing that calls fetch in our example. Okay, why? Like why we have like an adapter, like it's another top layer. Okay, so this is an actual case. Like we said, we have like container, we have like newsfeed, we have notification, and each one of these, like it doesn't have fetch directly, but rather it would now need a service for it. So we'd have newsfeed service, and you would have another one for notification. This is all of this doing API calls. You have another one, and you have a third one like not translation. Translation also a good example. You have translation, but you are using Google, for example, and like other services in this case. All of these are using like fetch. And today we are using fetch, like the one from the DOM. Tomorrow we would like to use Axios, because Axios maybe like it's easier, it's more able to use logging and so on. I don't know. Maybe you would like another, I don't know, like another XYZ library in the future to do API calls. Maybe we don't use API calls. We would use actually like cancel all of this and use GraphQL. We would like to use GraphQL in this case. So can you imagine going to each service and trying to replace all of this? It would be quite hard. That's why we have an adapter. And the adapter would be a single place that communicates with the third-party libraries that we have. So it would communicate with GraphQL. Like we would have in this case, GraphQL adapter. And we would have another adapter for fetch. So we'd have like another adapter. Okay, maybe I would clean this part just to make it cleaner. Yes, yeah, this would be better. So we would have here our fetch adapter. This is the old one, but there is another one there is GraphQL adapter. The idea is that, of course, like it is not using both of them, but rather it could change. Like today it is using Fetch, tomorrow it is using GraphQL. Like I would say here, yeah, I would like to use GraphQL. And the container still calls the service. So inside it, it would say, okay, get feed. Just an example. Of course, it would be like feed service.get, for example. And the service would say, okay, this is my responsibility to use Fetch. But instead of using Fetch, I would send it to our Fetch adapter, and Fetch adapter would do the actual get code. So inside Fetch, you have you have to write Fetch and then the URL, and then you have to write like the method body and so on. Inside GraphQL, you have to send like the whole query thing to get the node. But the good thing about this service or the other services, not just this service, they all call get only from whatever adapter is being used. So it would say, okay, HTTP adapter, please give me, or not the HTTP adapter, but rather adapter. It is passed like usually like as an adapter only. Would say adapter, get me this thing. Whatever this adapter it is like maybe it is using Fetch, it is using GraphQL, maybe tomorrow it is using XML, I don't know, like whatever technology it is being used underline. But inside this service, it would just call an adapter. Usually it is not used called an adapter, but for services, they call it API directly. And the API would be just a name for all of these things. And the implementation itself is held inside the adapter. And that's why we need this adapter. Something that implements the implementation of the third part library. And the services are the things that doing like the calls. Okay, I would like to hold like the URL, for example, in this place. Maybe this API needs some different variation for the API. Maybe it needs like different body or different headers and so on. So in this case, it would happen inside the service. But the actual sending and this part would happen inside the adapter. And that's why adapters need interfaces. It is not one of the 6 parts that we have mentioned. Let's remove all of these to have like a cleaner look. Yep. So we have here our Fetch adapter, and we have our GraphQL adapter. Yeah, we call it like A. And there is an interface. And interfaces, if you don't know them, it's probably better to look at them. It's just like it's a definition. It is like you could think of it like just defining different types. It defines methods in this case. It would say, okay, whatever class is being used by the service, it needs to have these methods. So it needs to have get, it needs to have post, it needs to have delete. Maybe inside the translation, it needs to have translate as well. So these would be the methods that are required for whatever adapter is being used. So today I'm using Fetch. Inside GraphQL, it needs also to have get, it needs to have post, it needs to have like the other different methods that it has. And in this case, I could replace this part easily. And the interface is just like inside the class, you would say the class implements this interface. And inside this service, it would say, okay, I would like any class that implements this interface. It doesn't directly call the adapter, but rather says, okay, give me anything that implements this interface. And in this case, I would be able to change this adapter with another adapter tomorrow. And that's why we have interface. This is just like something inside the language. TypeScript have it. Also PHP have it. Node.js have it. C++, and I'm not sure like if it's Rust have it as well. You could leave in the comment if it has it as well. Go.js as well. You could leave it in the comment. I don't have it like in top of my head, but it just like exists in most languages. So you have like this interface, but JavaScript doesn't have it because it's not a normal language. But TypeScript have it in this case. You would just like define an interface, and you would say, okay, this adapter implements this, and this adapter implements it as well. And the service is the thing that implements this part. Okay, so let's go to a new cleaner page again. So let's do again, because this is a little bit of an important video, and yeah, let's not forget. So we have, like we said, we have container, mixture of mostly logic and few UI, and we have component, and we have another component, and we have another component, many components. And you would have our lovely hat, which is the HOC, and our container or whatever other container, it would call a service, and this service would call a certain adapter to implement or like interact with a third party library, and it has like an interface in the middle. Okay, now comes the like how many? 1, 2, 3, 4, 5. Now comes the sixth part and the last part, which is a store. Okay, what is a store? So inside the container, we have a state. But what happens when we have another container that requires this exact state as well? What is a good example for this? A good example for this would be navigation. So you would have here your home page, you have navigation at the top, and you have like here different links, and you have a link here that requires to know what is the current page as well. And also navigation needs to know what is the current page. So you could say, okay, I would store it inside a service, but services are just functions. They don't have states. A state is just like the current state for the application. So it would be the current user identity or the current user data, the current appearing post or the current link. I'm just like taking a small example. It could be as well the current feeds. So you would have like different news feed, another news feed, and so on. So all of these stored inside a store, and the store is just cross-container state. So for feeds, for example, you need to have like feeds here, and you need like I don't know, like a counter for these, like the number of these fields. In this case, because it's cross-container state, you wouldn't store it in a single container, but rather in a store. And in this case, this is the only reason you would use store. Make sure that it is not a case for a container inside a container, because it might be this case that you just need to put like this container inside it. The idea of a container inside a container is just like hierarchical inside the UI itself. But if it's not hierarchical, but rather it is just like cross-container, in this case, you would need to use a store. It's something from the outside. And most probably it is not just 2 containers, but rather maybe like few, like 50 or 60 containers. You would have like many containers actually needing to use these different stores. And this is just the whole idea about store. It is just something to store the state for multiple containers. Okay, maybe there is now a question. I am sending the API call using the container, and the container would send it to the service, and the service calls the adapter, getting the post, and I will just read it inside the container. This is wrong. Because you are returning from the service, yeah, it would work, of course, like most of the things would work, but this is not cleaner. Because you are storing here inside the container, but this other container as well needs a news feed. So if you have like, imagine if you have like this page, and this page requires to get different menus, like we would say like this is restaurant, and there is another container that gets stats about this restaurant. In this case, it would call the API for the restaurant, and this one let's call like metadata. This is another container. For some reason you have this structure, and this would call the API again. You would call the API twice, and each one of these have its own like state inside it, because you stored it inside the container. Like this container has this state, and the other container has this state, because you call the server. But rather, instead of calling this, like getting the data inside the service wouldn't send it to the container, but rather send it to the store. So in this case, this restaurant would say, okay, get me the restaurant data. Fetch, in this case, not get. It would say fetch, just fetch them. And the service would say, okay, I will fetch them and send it to the store. And the store would change its state to have like the restaurant data and send it back to this container and this other cross container, and they updated at the same time. You would see like two observations. First thing, you would see the line is just unidirectional. The container calls the service and the service sends the store, and the store, which have like cross state state. Yeah, cross state. Yeah, lovely. It would send it back to the container. This is actually Redux. If you don't know, this is how Redux work. So instead of services, it's called actions. Like they call it actions. But basically our container calling the service, or in this case the actions, and the actions updating the cross store. So this is the whole idea about store. So this is the same exact thing of Redux. So it's a single direction. Some applications, they would have like the container as the container calling the service and getting it back, and you would see like another container doing the same thing. The best option is first just combine all of these. Like you have like a certain service, and inside the UI, instead of taking it back from the service, it would take it from a store and make the service update the store. Yeah, and now we see the whole image for the front-end application. So let's go to a new page just to do some recap about all of these lovely stuff. So like we said, we have our container, and the container we have inside this one component. Component is just storing the UI stuff, or mostly some UI, and container have like mostly JavaScript, less UI stuff. And we have our HOC hat here at the top, and the container would call a service, and the service would call an adapter. Yeah. And the adapter is the thing that implements the third party library here. And yeah, let's call it third party library. And we have here another container, and this container would have also the same thing, different components under it, and the cross container state would be stored inside a store. And the service usually most of the time would call the store, and I would think like most of the time, like if it's like a pure clean application, it would call the store. Yeah, this is most of front-end architectures that you would probably need. Of course, like there are many design patterns that exist, and we'll discuss them in this channel. So don't forget again to subscribe and like this video if you find it useful, and hopefully you find it useful and it makes your code base more cleaner. But this is most of the front-end architectures that you need to know about. Like most of your application would be built using it. So yeah, thanks for watching, and hopefully in the upcoming video you would see an application built using pure JavaScript using this architecture, and you would see an actual implementation of all of this. So yeah, thanks, and see you in the next video. Ciao.